All right, here's one more example of partial fractions and long division. We've actually got both in this example. We know that we need to start with long division because we have got that greater exponent on the top of our fraction than on the bottom of our fraction. And so we're going to start by taking our x cubed minus, oops, we need to leave a space for x squared minus 4x minus 10. And again, we're going to just look at that first term and what we're dividing by and the first term in what is being divided and say, how do we make x squared into x cubed? We do that by multiplying by x. So we get x squared, oh, not x squared. The whole point was to make that x to the third minus x squared minus 6x. So this statement is going to go here, again, lining up all of our terms and what we multiplied by. It's going to go right there. And then we are going to subtract here. So that's going to change all of our signs. Anything negative is going to become positive. Anything positive is going to become negative. Those first terms should always be an opposite. That's the whole point in what we did. And then let's see here, we combine our like terms. So 0x squareds plus one of them gives us x squared. And then we've got plus 2x and minus 10. All right, so now let's see here. We need to say, what would we multiply x squared by to get it to be an x squared? Well, it already is x squared, so we would just multiply by 1. And our quadratic would stay the same. So we just did 1 times our quadratic to give us that leading term of x squared. And then just like up above, we have to subtract both of those terms, or all three of those terms. And then those first terms should be opposite. And then we combine like terms and we get 3x minus 4. There's no way we can make an x squared into an x. So that's how we know that we're done with the long division portion of things. So we've got our original problem here. And then we just learned that this is x plus 1. So what we got from doing our division plus our remainder over our quadratic. And then just like in the previous example, here we've got a rational function that here we need to use that partial fraction decomposition. So we need to pull this apart. So we're going to look at our 3x minus 4 and x squared minus x minus 6. Let's see, that is 3x plus 2. So we get that we're going to split this up as a is x minus 3 and b is x plus 2. And then we're going to multiply by that common denominator. Sorry, it takes a little time to write all that out. There we go. So that should cancel out all of our denominators, and we get 3x minus 4 is equal to a times x plus 2 plus b times x minus 3. And remember, we have two ways that we can do that. We can use that strategic substitution, or we can solve this as a system of equations. It really doesn't matter. I think I might pick strategic substitution and again plug in those values that make our denominators 0. So positive 3 and negative 2, we're plugging those into every place where we have an x in our equation right here. So we're going to get 3 times 3 minus 4 is equal to a times 5 plus b times 0. So let's see, that is going to give us 9 minus 4. So that's going to be 5 is equal to 5 times a. So a is going to be 1. And then when we plug in negative 2, we're going to get 3 times negative 2 minus 4. We're going to get a times 0, but then we'll get b times negative 5. And so on our left-hand side here, that's going to be negative 10 is equal to negative 5b. So 2 is equal to b. So now what we figured out, let's take our fraction here. Let's copy it and paste it down here. let's see, I'm going to erase that. And maybe what we'll do also at this time is kind of put this all into integrals for us. So we started off that we wanted this integral, and then we got here with our long division. And then our x plus 1, that part was already done. So this work that we did up here was just to get this fraction here broken down a little bit more. And we learned we could break it down with 1 over x minus 3 and 2 over x plus 2. And so now we can take our integral. This one's not bad at all. And so we get 1/2 x squared plus the natural log of x minus 3, and then 2 times the natural log of x plus 2, and plus our constant.